Okay, start recording. So we are recording. Okay, so let me go to my weekly activities folder and we will continue reviewing for our final. So let's see. Let's resume. Okay, so let's see. We had already done the first, I don't know, I think we went through the first 15. Okay, yeah. Let me go to 16 and then I'm just going to do this. Excuse me, y'all. Let me grab my. I really should label my stuff. I don't know why I don't do that. I know. I keep saying, "Oh yeah, I'm going to do that," and then never do. Is this us? This looks like this was us here. Yeah, this is what we were. Okay, yeah, here we go. Okay, so let's take a look-see here, you guys. Let's come back here. This is number 16. And it says the function f of x equals 2x to the third minus 33x squared plus 60x plus 4 has one local minimum and one local maximum. Okay, so what I'm going to do here, I'm going to do a little copy and paste. And we will see if we can't figure this thing out. So let me copy that. Come back down over here and let me paste it. All right. Okay, so we want to find our local max and our local min. So y'all, if you remember what we're supposed to do here, we need to find our first derivative, right? Okay. Yeah, we're going to find the first derivative. Okay, so let's do that. So let's see. We need to take the derivative of this function right here. One piece at a time. What's the derivative of 2x to the third? 6x squared, okay. Minus the derivative of 33x squared? 66 with an x. And then what, plus 60? Okay, so now y'all, we're going to find our critical values. So the way we find our critical values, let's go like this. So number one, the derivative. Number two, we're going to find our critical values by taking the derivative and set it equal to what number? 0. Good. Okay, so the first thing I'm going to do, I'm going to divide everything by 6 just to make my life hopefully a little bit easier. Okay. So guys, this should be hopefully be one of those easy breezy cover girl factoring problems, right? We can go x and x. Yes, -1 and -10. Remember, we're looking for two numbers that multiply to 10, but when we add them, we get a -11. So -1 and -10. So then when we set each part equal to 0, yeah, we're going to get x equals 1, and we're going to get x equals 10, right? Okay, so remember, you guys, we're now looking for we're looking for local maximums and we're looking for local minimums. So what we can do, you guys, this is the first derivative test, okay? So step number 3, I'm going to write it right here, and I'm going to call this the first derivative test. Let me see. I thought I heard a little something here, but I'm not sure. Let me double check. No thumps. Okay, who's here with us anyway? Somebody's coming in. Who's coming in? Not the us that's coming in. Okay, good. So guys, first derivative test says we can do this. We can put our two numbers down. One of them is 1, the other one is 10, okay? What we're going to do is we're going to pick test numbers, okay? So we're going to pick a number between, remember, over here, you guys, on my number line, this is -infinity, this is positive infinity. So we broke up the number line actually into 3 pieces. So I need a number between -infinity and 1, 0, okay? Then we're going to pick a number between 1 and 10, 5. And then we need something bigger than 10. Let's go with 15. Okay, what we're going to do now is we're going to look at the sign of f prime, okay? So guys, the sign of f prime. So what we're going to do is everywhere we have an x, we're going to plug in a 0, we're going to plug in a 5, we're going to plug in a 15, okay? Now, guys, I want you to notice from here, what we did is divide it by 6. We could have also said we were kind of like factoring a 6 out, okay? The 6 isn't really important because it's a positive number. We divide it by a positive number. And I'm thinking about in terms of like inequalities, it doesn't affect when I'm thinking about an inequality, when I divide by a number that's positive, it doesn't affect my inequality, okay? I'll show you in the case, what happens if it would, and I'll talk about that in a second. But what I want to do, y'all, is I want to plug in these test numbers back into this part right here, okay? So again, I think the way we actually did it was when we were doing this when we actually went through this, I think we actually entered this number into our calculators, right? So we probably came back over here and we said, look, let's do a little y equals, and we plugged in this, whatever it was, right? 6x squared. So look, 6, what is it? X squared minus 66x plus 60, right? That was my derivative. Okay, let me quit that. And then we're going to go to our y bars, right? So we're going to go to bars, right here, y bars. We're going to function, the first one. We're going to evaluate this at 0. And guys, all we're interested in here is the sign of our number. Okay, so the sign of my number here, the sign of f prime, in this case here, it was positive. Okay. Now look, we're going to do the same thing again. We're going to do y bars, but we're now going to plug in 5. When we plug in 5, it is negative. Okay. And then we're going to do this one more time, and we're going to plug in now 15, and it's probably going to be positive. Okay. So far, so good? Okay. So guys, then what's happening with the function f, if the derivative is positive, that means that the function is increasing. If the derivative is negative, that means that the function is decreasing. And then if it's positive, it is increasing again. So I want you to think about what's happening with my graph in a rough sense. My graph is going up, and it comes back down, and then it goes back up. So this here would be what we would call our maximum, and this point down here would be what we call our minimum, okay? So we have a maximum at x equals what number?
X equals 0.
Well, hold on. What's the max? When x is equal to what? When x is equal to 1, right? And we have a minimum when x is what? Okay, so look, guys. First thing I'm going to do here, the first one is asking me where's the minimum, and if you notice, our minimum was at 10, right? So I'm going to put a 10 right here, and our maximum was at 1. Now, what we need to do is we need to find the function values at that number, right? So then, guys, all I'm going to do is I'm going to come back over here. I'm going to go to my y equals, and I can go ahead and just clear that guy out. I don't need it anymore. And I'll type in a 2x to the third, okay, minus 33x squared plus 60x plus 4 at the end. Oh, but remember, I'm plugging in the original function.
Okay.
Right, so 2x to the third minus 33x squared plus 60x plus 4. Okay, so let me enter that guy in, and then I'm going to quit. I'm going to come back to my y bars. Oops. My y bars, and we're going to evaluate this, you guys, the first time at 10. Okay, so let's go here at 10. Negative 696. Is anybody else coming up with the same note? John, did you get the same thing? Did you not?
I got negative.
Okay, so let me check my y equation again. So look, I have a 2x to the third, a minus 33x squared, a plus 60x, and a plus 4. Okay. Okay, good. Okay, so now then we're going to go to our y bars again, you guys, and we're going to evaluate this now at 1. Okay, and I'm coming up with a 33.
Honest question.
Uh-huh.
Does this flow because I know the zero thing?
Uh-huh.
Once I find my zero, once I just plug them into the original function, and then whichever one's the larger one will be the maximum, and whichever one's the smaller one is the minimum?
Yeah, it does the same thing.
Okay.
Yeah.
I wasn't sure if that was like the reason we did the 0, 5, and 15 thing.
Yeah, Now,
Is
the
that
only thing is that sometimes there's questions that'll ask you over what intervals is the function increasing? And if it says over what interval is it increasing, we would say, look, it's increasing between negative infinity and 1, as well as 10 all the way to infinity. Does that make sense? So there's certain advantages to the first derivative test, but yeah, if it's asking you that, yeah, that's fair. You can do it like that with you.
I wasn't sure because like I was wondering maybe there was like a rule or like there was like exceptions to this like
Yeah,
this
no
algorithm
real
that we
exceptions.
use.
I don't think so. I just think if the question asks you for like say intervals for the function is increasing or decreasing, then yeah, you're definitely going to want to go through that part. Guys, I mean, I want to know, y'all to notice something. The way we found, those whether the sign was positive or negative was we took the derivative, right, and we plugged that into our calculator, okay, and then we did our test numbers. And again, the calculator saves me a ton of time doing this stuff, right? I don't. I mean, I'm gonna ask you guys a question. I want you to look at this problem here. Remember when I said, look, here was the factored form? Okay, remember what the first number we were plugging in was what number? 0, right? Okay, so look, I'm gonna just show you something here. If you plug in 0 into this part right here, I want you to think about that. Look, I already have the number 6. Okay. If I put 0, what's 0 minus 1? Negative 1. Okay, good. What's 0 minus 10? Negative 10. Would that number, when you multiply them, be positive or negative? Be positive, right? Now look, we're going to do the same thing with 5. So look, I already have the 6. 5 minus 1 is 4. 5 minus 10 is a minus 5. Isn't that number negative? You see the game I'm playing? So guys, and the only reason I'm telling you this is we kind of do that step in college algebra. And when we do what we call polynomial inequalities, and when we do it, I always kind of show them, and I always tell my students, it's easier to plug it into the factored form than it is to plug it into, like, say, this form, if you're going to do it by hand, right? Because if you can do it in the factored form, it's really easy. You see, oh, look, I have, 2 positive numbers, or I'm sorry, I have 2 negative numbers. Oh, I know my answer is positive. I only have 1 negative number. Oh, I know my answer is negative. Oh, I don't have any negative numbers. Oh, and I know my answer is positive. So just a little sort of like hint. If you wanted to do it by hand, you could do it that way. I know when we went through it in class, guys, we just used our calculator, and it saves us time, right? But if you don't feel like messing with all that stuff, and then the only other thing, guys, is remember when you're doing to find the actual minimums and maximums, you have to plug them into the original function, right? So when we did this part right here, we came up with that 696 and that 33 by plugging into the original function, right? Not the derivative. So you just got to be careful about that. So look, let me check my answers here. I got a 10 and let's see, a 10 and a negative 696. And then we had a 1 and I want to say it was a 33. Right? Those are the numbers? Yeah. Okay. And let's come back this way. Let's submit it. Hey, we're doing great so far. Okie dokie. So now let's take a look at number 17. And again, you guys, I'm just going to do a little copy and paste. So let me copy this guy here. Come back down over here. Well, I'll get there in 1 second. So guys, look, when we're evaluating these limits here, there was a couple of rules, and I know this here, I believe this rule, we had it in the formula sheet for test 2. But the idea is what we're doing is we're looking at the degree of the top and we're looking at the degree of the bottom. Okay, so when we're looking at the degrees, guys, this applies when I'm taking limits going towards infinity or negative infinity, okay? There's basically 3 case scenarios. Number 1, the degree of the top is equal to, yeah, where am I? Right here. The degree of the bottom. Okay, in that case, my limit is going to be a over b, where I'm looking at the fraction of those leading coefficients. That's right. Number 2, you guys, and I'm just going to go through the rules just so that, again, you understand, right? Now, suppose the degree on the top is smaller than the degree of the bottom, that would mean that either, let's put it this way, that would mean that that would have to be bigger than an x to the third, okay? Because the degree of the top is going to be smaller. Anytime it's smaller, it's going to be y equals 0. That's right. And then the third rule is what happens when the degree of the top is bigger than the degree of the bottom? Then the limit as x approaches either positive or negative infinity does not exist. Okay, it goes to infinity, guys. It either goes to positive infinity or it goes to negative infinity. Okay, but it doesn't exist. Right. That's right. That's why we say it doesn't exist. Okay, so look, guys, in this case, y'all agree that we fall into the top category? Okay, so my limit's going to be 5 over negative 5, which is just a negative 1, right? Okie dokie. So let's come back over here, and then, John, I'll definitely get to the L'Hopital's rule in 1 second.
Is that not it?
No, that's not. I'm going to show you when we're going to do L'Hopital's rule. We'll do that. I think it comes in. I forget what question it is, but it's going to be there. You probably can use L'Hopital's rule there. Yeah, you can use L'Hopital's rule there too. Yeah, that's definitely the case. Okay, so look, y'all, we're gonna do this problem here, and again, this is one that we did. You know, we had the same problem on test 2 when we kind of went through the same question here, but let's go through it again just to make sure that we're good. Okay, let me copy this here. Let me scroll down, Charlie Brown. Let's paste this guy right here. Whoa. Okay. So it says a box with no top is made from a rectangle of dimensions A equals 6 inches by B equals 5 inches by cutting a square at the side of each corner and turning up the sides. Okay, determine the value of x that results in a box with a maximum value. Okay, so let's take a look here, you guys. We know that the distance from there to there is 6. We know the distance from here to here is 5, right? What we need to find first is what is the distance, say, from here to there. So look, we took off an x, we took off another x. So we really took off, what, a 2x? So this distance, very good, thank you, John, is a 6 minus 2x. If we took this x off and we took that x off, wouldn't this distance here be 5 minus 2x? Okay, so look, you guys, I'm going to draw my picture of my box. It's going to look something like this. What do you mean? Like a... Okay, so look, at the top, guys, this distance here is 6 minus 2x. This piece here is 5 minus 2x, and that's going to be x, right? Okay, so now look at step number 1. Step number 1 says express the volume V as a function of x. Okay, so remember, y'all, when we're finding the volume of a box, it's the length times the width times the height. So we're just going to multiply each of those pieces together. Okay, and let's see. I don't even know if it. I'm pretty sure my open math is pretty forgiving.
No, that's correct.
We can just write it this way. Okay, so we'll write it that way, guys. If it doesn't let me do it, we'll fix it. You know, we'll multiply it at the end, right? Okay, now the only reason I'm leaving it that way, guys, is remember, what we're trying to do is we're also going to find the domain. Step number 2 says we want to find the domain of the function. Okay, so guys, we actually have 3 parts to this function. We have the height, we have the width, we have the length, right? Whichever one you want to call what. And we know that all those pieces need to be positive. Okay, so look, I'm going to do it this way. This first piece, x, has to be bigger than 0, okay? The second piece, 6 minus 2x, also has to be bigger than 0. So when I move that 6 over, I get a negative 2x is bigger than 6. But when we divide both sides by a minus 2, we actually come up with x is smaller than 3, right? Okay, and then we have one other piece. We have this 5 minus 2x also has to be positive. So when I move that 5 over, I'm coming up with, let's see, you know what? That 6 should have been negative, right? So that makes this a positive 3. My bad. Okay, so when I move that 5 over, that becomes a negative 5. And when I divide everything by negative 2, this is telling me that x is smaller than 2.5. Okay, so guys, just to give you a heads up, look, I'm going to draw my number line here. Okay, remember, over here is negative infinity. Over here is positive infinity. Okay, first thing, x is bigger than 0. So I'm going to leave that circle open, and I'm going to shade everything to the right. Okay. Then I'm going to go, I don't know, in red, and I'm going to do, here's 3. I'm going to leave that circle open, and I'm going to shade everything to the left. And then I also need to do 2.5. So 2.5 is somewhere right about there. That circle is also going to stay open. And again, we're going to shade everything to the left. So what we're looking for is everything that we triple shaded. So yeah, so from 0 to 2.5. And with the circles being open, so you guys, in terms of interval notation, it looks like this. From 0 to 2.5. Okay. Yeah, because it can't actually be 2.5, and it cannot be 0 itself, right? If it's 0, then that means that the height of my box isn't there, right? The height would be 0. And if I was actually at 2.5, then I wouldn't have a width of my box either, right? So it has to be the open interval, okay? So look, guys, right here, I'm just going to go from 0 to 2.5. Okay. Now, to do the derivative of the function, I'm going to go ahead and multiply the function out, okay? So I guess, you know, I can enter it in either way, but let's go ahead and FOIL this guy out. So look, guys, I'm going to do this part first. So 6 times 5, I'm going to leave that x out here. 6 times 5 is 30. 6 times a negative 2x is a minus 12x. That gives me a minus 10x. And that gives me a 4x squared. So minus 12 and minus 10 is a minus 22. Thank you, John. And so now my derivative should look like, or my function actually should look like 4x to the third minus 22x squared plus 30x, right? So this is the actual volume, right? All I did is multiply the whole thing out. Now let's find our derivative. Okay. 12x squared, very good. The derivative of a minus 22x squared? There you go. Excellent. So right here, you guys, we're going to enter in 12x squared minus 44x positive 30. Okay. Now we have to find the zeros of this function. So guys, remember what we're going to do, we're going to set this thing here equal to 0. And I'm probably going to, so guys, Matthias did send me a program that you can actually type into your calculator that'll help you solve this right here. This was the other thing. So I looked up a video on how do I use that equation solver thing. So look, if I hit math and I hit solver right here. Okay, so the first thing is the equation has to be set equal to 0. And if you notice, it's already set equal to 0, right? So this is how you do it. It's kind of, I don't know. I don't understand why it's set up this way, but it's set up this way. This is not the program that Matthias sent me, though. He sent me like a program that you can actually type into your calculator and it'll do it for you. Okay. So look, I'm going to hit enter here. Okay. So the way this thing works is the first right here, it gives you a value of x. Like by default, I guess it's equal to 0. What you're supposed to do is you're supposed to guess, what do I think my answer might be? And it's going to give you, I know it's kind of silly, it's going to give you an answer close to that. So this is what I'm going to do, guys. I'm just going to say, look, I don't know, -5. And when I hit enter, or is there a solve button? I want to say there's a solve button somewhere. Oh, here we go. Right here, right above my enter, there's a solve button right there. So I'm going to have to go alpha solve. And did it give me anything? It did not. Okay, no. Alpha solve. Okay, so look, here's the first answer that it gave me. It said the closest answer to -5 was 0.9, 0.9053. I'm going to put 0.9054. Huh? Yeah. So look, the answer I'm coming up with 0.0954. Okay, now I believe I can come back to this again. And let me see. Let me quit this thing here. Yeah. And if I go back to math and I go back to equation solver. Oh man. Okay. So the next number I'm going to guess actually something even smaller. I'm going to go -10. Okay. And I'm going to go solve. And it's still giving me the same answer. I have to pick a positive number?
Anything bigger than.
Okay, so let's try that again. So let me quit here. Math.
Anything bigger than 0.95, right? Is there a way to check?
Well, I'll put it this way. Let me go like 9. Yeah, it actually is a bigger number. That's right, it's 9. Not that it's 9, but it has to be a bigger number. So I'm going to go solve. Okay, and the other one I'm coming up with is 2 point. That doesn't seem right.
2.7612.
Yeah. Are those answers you came up with, John?
Yep.
You got the same answers? Okay. Oh, yeah, it is. It is. Yeah. 2.76, what was it? 13 or whatever? Okay. So look, those are the two answers that I'm coming up with, right? So right here, guys, I'm going to put a 0.954 and a 2.7613. Okay, if I didn't want to mess with that equation solver, again, what I would do, guys, I would do the quadratic formula, okay? Those are the two answers that I got. Now, hold on, I'm not finished quite yet because I know there's still more part of the problem, so I didn't get to copy 5, 6, 7, and 8. So let me copy parts 5, 6, 7, and 8 here, and then we will answer our question. Okay. So let's come back this way. Okay, there we go. So the value of f at the left endpoint, or the value of v, I'm sorry, at the left endpoint. So guys, what I'm going to do is I'm going to enter my original function in, okay? So look, let me go ahead and quit this here. Let me go back to my y equals. Okay, guys, the function that I'm going to enter in is this 4x to the third minus 22x squared plus 30x, okay? Because that's my volume function. So 4x to the third minus 22x squared plus 30 with an x. Okay, enter. Okay, let me quit that. Let me come back to my y bars. Right here, we're going to evaluate our function. The first time we're going to do this, you guys, we're going to do this at the 0.9504. So 0.9054. Okay, and I am coming up with about 12.0963. So 12.0963. 12.0963. Okay, we're going to do this now at the left endpoint. So I'm going to just do the same thing we did before, second entry. But now I'm evaluating this at 2 point something. 2.7613. There we go. And I'm coming up with like a negative 6.889. Yeah, negative 0.6889. Okay, so what is the maximum volume? Wouldn't it be the 12.8 or 0.0, sorry, 12.0963? Okay, and what is the value of x that maximized that? The value of x that did that was the 12.9054. And now, guys, I can come back and I can enter my answers in just like I wrote them here. So I'm just curious if it's going to let me enter the function in here like this, like x, and then we had a 6 minus 2x and a 5 minus 2x. Okay, so I'm going to leave that like that. And then my interval was from 0, 2.5. Okay. The first derivative looked like what? 12x squared minus 44x plus 30? 12x squared minus 44x positive 30. Okay. Critical points. How do you, when you guys enter the critical points, 0.0954, so you do it like almost like an ordered pair?
Yeah.
Okay. Point 9054, 9054, comma, 2.7 something or another. 613, 7613, let's see.
We found the critical points of the derivative of the. Is that okay?
Yeah, that's how we find the critical points.
Of these?
Yes, is by finding the critical points, and that's right. That's right. Yes, sir. So look, 12.0963 for this one. 12.0963, and then this was like a negative something or another. Negative 0.6889. Negative 0.6889. The maximum volume was the 12.0963, and that happened at 0.9054. Okay, let's submit it. Let's see if we're good. Oh, we missed something here. Use of a comma. And then these numbers aren't right either. Let's see, 0.9054, comma, what was the other one? 2.763? Like that. And then the left endpoint. Okay, so you know what? These numbers, I have them the wrong way. There should be a negative 0.6889, and this one should be the 12.096. 2.7, I'm sorry? Okay, thank you, John. Like that? Okay, let's check that now. We're still missing something wrong here. And why are these still off? Let me see. Okay, you know what? Okay, this is why. My bad. Find the critical points in the domain. 2.76 is not in the domain. Right? Okay, the left endpoint. ¿Por qué? No. At the left endpoint. At the left endpoint, it was point. This is the left endpoint. And when I plug that in, that should be. Why is that not working out? I'm going to try something here. I don't know why this is not working out. 12.09. Like that again. No, still missing part of it. Oh, it says they're both wrong. I know a while ago it said that one was right.
Maybe it's 0 and,
The value of v at the left hand point. Man, what am I doing wrong here? Okay, let me see. Where are we making our mistake?
If you have two endpoints of the interval, there shouldn't be 0.
Oh, I guess so, yeah. So let's try that. Let's see this. Let's put a 0 here, and then this would also be a 0, wouldn't it? Oh, you know what? Yeah, it would be a 0, right?
So what was our number line thing?
The number line was from 0 to 2.5. I'm wondering if that's what they're referring to. Because if I plug in a 0 into my function here, it's going to give me a 0, and I plug in a 2.5, it's going to give me a 0. Let me try that. That's what it was. Okay. All right. Okay. My bad, guys. Yeah, okay. I was off on this part here. I wasn't sure what they were asking about. So let me come back, guys, real quick. My bad.
Finding the value of v at the function.
That's right. Okay. So look, guys, this is my bad right here. When we're doing parts, let me zoom in real quick. Sorry about that. Okay. So remember, this was our interval in my domain, right? So my interval in my domain was from 0 to 2.5. So they're asking me, what is the value of v at 0, and what is the value of v at 2.5? That's what they're asking me to do. So I want to show you guys something. So look, remember when we had our volume function and we left it in the factored form right here? So look, what happens if you plug in a 0 everywhere you have an x? Well, that number right there, the first time would be 0. So 0 times anything is going to give me 0, right? Okay, the second time, when I plug in 2.5, look what's going to happen right here. 5 minus 2 times 2.5, that is 5. 2 times 2.5 is 5. That's going to give me a 0. 0 times anything else is going to give me a 0 there. Okay, so that's what they were trying to get at. Okay, so sorry about that, guys. I wasn't sure what they were. I thought they were talking about the endpoints, and I guess I should have been more careful with it. But what they're referring to with the endpoints are the endpoints of the domain, not the endpoints of my critical values. Yeah. Yeah. Does that make more sense though now? Okay, that was my bad, guys. Okay, so yeah, there you go, right? There you go. Good, good, good. Okay, so we finally figured that one out. Okay. Um, so let's go ahead and jump over to the next one. This was number, yes, so we finally got it right. Hey, the nice thing is, and I think I'd set up the test the same way, so you get a couple of tries, right? So it's not either right or wrong. Like you don't have to do a whole problem. Here you go, John. John's problem right here. John was asking about L'Hopital's rule. And so, yeah, this is our L'Hopital's rule problem, okay? So look, we're gonna copy this guy. And so, John, your question earlier was, can we use L'Hopital's rule on the other one? Yeah, you definitely can. Really, we can use L'Hopital's rule at any point in time, right? The couple things that have to happen is that it has to be an indeterminate form, right? So, okay, so one thing I would say is, look, they're telling me to use L'Hopital's rule, so I'm going to do it. But again, just so that you know why we can use L'Hopital's rule, if we were to actually plug in 0, e to the 0 minus 1 would be 1 minus 1, which is 0. Okay, sine of 4 times 0 would be sine of 0, which is 0. So when we have something, that's what we call an indeterminate form. So you either have 0 over 0, or you have like infinity over infinity. That's when you're going to use L'Hopital's rule. So remember, what we're going to do, you guys, we're going to take the derivative of the top. So the derivative of e to the x minus 1 is just e to the x, okay? Now, we need to take the derivative of the bottom. So the derivative of a sine is a cosine 4x. One other piece, the derivative of the angle. Okay, don't forget to take the derivative of the angle. So guys, the derivative of 4x is a 4, okay? Now we can take the limit. So e to the 0, yeah. So e to the 0 gives me 1. Cosine of 0 is also 1. So here, guys, we should end up with a 1. Okay. So, and I don't know if you guys remember or not, but when we did L'Hopital's rule, there were certain problems where we had to do L'Hopital's rule like twice. Okay, this is not one of them. This is a very straightforward type problem. Okay. But again, just to give you an idea, guys, the reason that we have to use L'Hopital's rule is because we end up with that indeterminate form, right? We end up with a 0 over 0. Okay. So our answer here, y'all, is 1/4. So let me come back over here. So 1 over 4. I'm sure we could have put 0.25. Yes, ma'am. The one that let me come back. This one right here? Okay, what I did is, remember how we found our critical values? We took the derivative, right? And we set it equal to 0, right? So these are the two numbers that we came up with, right?
The maximum volume has to be the domain of the function.
Yeah, so that's why when it said find the critical points in the domain, okay, we're not going to use that one because this number here, it's not in the domain, right? But this one is, right? So then what we did is we took this number here and we plugged it back into the original function. Yeah, because remember what it's asking? It's asking to find the maximum volume, right? So getting that number right here, Jennifer, all I did is plug that back into the original function. And that's how we come up with our maximum volume. Is that better? Good, good. Excellent. Good questions. Okay, so take a look here, y'all. At the next problem, let's see. Let me scroll back to number 20. Here we go. So remember, we are looking for an indefinite integral. Okay. Remember, guys, indefinite integrals are just antiderivatives, right? It's just the antiderivative here. Okay, so we're going to do this in pieces. So the first thing we're going to find is, what is the antiderivative of 4x to the third? Would it not be 4x to the fourth over 4? And then we'll do all the simplifying in a minute. And then the antiderivative of 6x squared should be 6x to the third over 3. Okay, and then don't forget our plus c, which they already have out there for us. And then now we can just simplify this. So that's going to be an x to the fourth, 2x to the third, plus c. We don't have to worry about the c because they already have that there for us there. So x to the fourth plus 2x to the third. So right here, y'all, I'm just going to go x to the fourth plus 2x to the third. And there's my plus c. Let's check it. Yeah. All righty. Okay, so this is number 21. Let's take a look at 21 here. This is very much plug and chug, yeah. So look, y'all, they give us some pieces of info here. They tell us that the sum from 1 to 116 of AI is -7. And they're telling us that the sum from 1 to 116 of BI is a -24. We are now trying to find this sum. So all we're going to do is we're going to go -1 times the sum from 1 to 116 of AI is a -7 plus 24. The sum from 1 to 116 of BI is a -24. Yeah, I guess not. Okay. Take that guy off, take that guy off. So that is a -7, and then whatever 24 times -24 is. +7, sorry. So 7 plus -24 times 24. -569 is what I'm coming up with. Yeah, that's +7 plus whatever it was. So negative 569. Let me check that. And there we go. Yeah, that's pretty much plug and chug, isn't it? Yeah. Okay, so look, guys, here we're definitely going to have to do a little bit of drawing, right? Okay, let me copy this guy. Let's throw it down here, and let's paste it. Okay, it says approximate the area under the curve graph from x equals 3 to x equals 7 using left endpoints with 4 subdivisions. Okay, so from 3 to 7. Okay. Yes. So guys, remember the first thing I'm going to do, I need to find the width of each of my rectangles, right? So the way I find the width is I'm going to take these numbers here. I'm going to go 7 minus 3 divided by how many subdivisions we have. So this is 4 over 4. So the width of each rectangle is going to be 1, right? Okay, just to make sure that we're good there. So what we're going to do is we're going to draw rectangles using what we call the left endpoint. That's 1 rectangle. That's 2 rectangles. That's 3 rectangles. That's 4 rectangles. Okay. So yeah, I might say, yeah, that's like say 2.6. This one here, we're good with 3? 3.3 or 3.2 or whatever you want to do. And then, I don't know, 3.7. Okay, so now we're going to add each of those rectangles up, right? So guys, remember, since the width of my rectangles in all of these cases is 1, the area is going to be length times the width. But the width is always what? What's the width in this case? The width is 1, right? So isn't the sum just going to be adding up each of those lengths? 2.6 plus 3 plus 3.3 plus 3.7. So this is 5.6, and that's going to be 7. So we're coming up with about a 12.6. Okay. Yeah, right. They're pretty, like you said, lenient with it. 12.6. Let's see, are we good? Man. Oh yeah, let's see. According to them, 12.62. Man, we were right there, right? Like by a hair. Right? And then again, you know why this is the way, you know why this answer is coming up like that? Because I actually found this equation of this curve, and they actually, you know what I'm saying? Like they did some more like they did like some major approximation there, right?
Or they just like actually do the equation of the curve.
Yeah, that's what I mean. They found the equation of the curve, right? Okay, so now let's take a look at number 19 here, you guys, or what number is this? 23, sorry. 23. Okay, so let me do a little copy and paste again, and we're going to do some U substitution. Why? It's all about U. Okay, so let's take a look. Lie down. I don't use that line often, but I've been using that line since like 1999, since I first started teaching. Okay, so look, guys, I like this problem a lot because they're very descriptive, right? They're very instructional on how to do the problem. Look, they're telling me let U be equal to x squared plus 3x plus 9, right? So then remember, we're going to find du dx, which is going to be 2x plus 3. Then remember, I'm going to move my dx over here. So du equals 2x plus 3 with a dx, right? Okay, and now we're going to integrate. Okay, this and that right there gives me my du, doesn't it? And this piece right here is u, but it's not just u, it's u what? U squared. Okay. So now we want to find what is the antiderivative of u squared. Wouldn't it be u to the third over 3? Yeah, plus c. And then now all we're going to do, guys, is we're just going to go back and resubstitute. X squared plus 3x plus 9 to the third over 3 plus c. Again, I don't have to worry about the plus c because it's already there. So that's what I'm really entering in, right? X squared plus 3x plus 9 to the third over 3. Let's try that. So fraction, parentheses, x squared plus 3x plus 9 to the third, right? And then all divided by 3. And let's submit it. Kind of digging that problem. Yeah, we're going to do a little plug and chug stuff here, guys. Okay. So remember, this here is using what we call the fundamental theorem of calculus. Fundamental theorem of calculus, excuse me, it's just telling me what we got to do is, let's see. Everywhere we have a t, we're going to replace it with a what? Okay, so we're going to put x squared to the fifth, but then we need to take the derivative of that upper limit, right? And the derivative of that upper limit is a 2x, right? Okay, so now I'm just going to go ahead and multiply this out. So x squared to the fifth should be x to the 10th, because we multiply our powers, times 2x. Isn't that going to give me a 2x to the power 11?
Yeah.
And that's what I'm going to put right here, you guys. And we're done.
So when they say the fundamental theorem of calculus, does that mean that this is like what all calculus is based off of?
I guess so, yeah. Yeah, should be. 2x to the 11th. Let me check my answer just to make sure that I'm not poking you guys in the eyes here. 2x to the 11th. Submit it. Boom, there we go.
It's Newton, right? In calculus?
Uh-huh.
The Newton and that other German guy, we're doing calculus. All their proofs were based off like this proof of calculus, basically. Like the whatever.
Are you asking me?
Like in theory, like if that's like when you, if they, it needs to be like those books are like the proofs, right?
Yeah, yeah.
So it's proofs upon proofs upon proofs. So they use that as like your base proof.
For some of the stuff, I'm sure they did. Guys, just a heads up here. Look, if I was doing this problem here, originally the way we did this problem is we probably did some use substitution here as well, right? But remember, now we have, yeah, and we found that we can use the function integral, right? Okay, so look, guys, let's see. I'm trying to see if I can remember how to do this. Didn't we go 8 and then parentheses 2x plus 1 to the third power, okay? And then wouldn't we go comma x, comma my lower limit, which is a negative 0.5, comma my upper limit, which is a 2. And I'm going to check. I can check. Oh my God! I'm going to check. I know on my calculator app it tells me exactly how to do it when I actually use it. So I'm going to check to see if I can just do it that way. Let me see. Math, function integral, function integral, expression, variable, lower level, or variable lower limit, upper limit. So yeah, we got that there. Okay. So let me see. If I hit enter, I'm coming up with 625. Right? $625. So I'll come back right here, type in 625, submit it. There you go, right? I don't have to worry about, doing it by hand anymore because we know that we can do it like that. Now, guys, one thing I do want to mention, look, what we did right now, it works for what we call definite intervals, right? When I have those limits. If I have something like this problem here, or we have a problem like, let's see, this one here, I can't do right, I actually have to find the antiderivative. The calculator saves me a little bit of time when we have a definite interval, right? Otherwise, on John, on your calculator, you might be able to do it, but I know on mine. Okay.
Because like this may or may not be correct.
John, let me ask you another question real quick. On your calculator, do you have, when you go to math,
Sure.
okay, after solver, do you have one called polyroots?
Yeah, I have solved, factored, expanded, zeros, and there's a specific option, like a whole section called polynomial.
Yeah. Okay, I'm gonna check to see, guys, if I can do something on mine, but I'll check in a little bit.
Mine's not crazy. I can find the root, the complex, the name of the polynomial, the quotient, the greatest common divisor, the coefficient, and the degree of the polynomial. So most of these you can just do on your own in your head, but
Yeah.
cool.
Okay, so look, guys, we're going to do the next part here. We're going to find the area between the graphs of 19 minus x squared and y equals negative 3x minus 21. Okay, so first thing we need to do, guys, we need to find where those two graphs intersect each other. Okay, where do they intersect? So the way we're going to figure that out is we're going to set the two equations equal to each other. So y equals 19 minus x squared and y equals negative 3x minus 21. So I'm going to go 19 minus x squared equals negative 3x minus 21. And I think I told you all this before, but it's much easier when the x squared is positive. So I'm going to move the x squared to the right side. And I'm going to subtract the 19. So that's going to give me x squared minus 3x. Let's see, that should be minus 40, minus 21, and that gives me a minus 40. Okay, so guys, now I'm going to go ahead and factor this guy out. So this is going to be x and x. So I want to say I'm going to have a minus 8 and a plus 5 because negative 8, positive 5 gives me a negative 40. When I add them up, there's my negative 3. And so the two answers we're going to come up with are x equals 8 and x equals negative 5, right? Okay. Now, the second thing is we need to figure out which is the upper graph and which is the lower graph, right? So guys, one way you can do that is, let me clear this out here. You can go to your y equals, and you can just graph the two functions, right? So 19 minus x squared and negative 3x minus 21. Okay. And then I'm going to go to graph. Okay, so look, there we go. Okay, so guys, and again, if I want to do, I can look at my window, so I can say, look, I want my window here, my x minimum to be, say, a negative 6, my x max to be a 9, and then let me try looking at the graph again. Okay, so I can, and look, guys, just by looking at this thing here, and again, I might need to make my window in terms of my y a little bigger and a little smaller. So I don't know, let's go negative 25 and make my y max 25. Look, that goes like that. That goes like that. So you can see that the x squared graph is the top function, right? Does that make sense? Are we good on how I'm kind of looking at? Question, Jennifer? Okay, so look, this is what I'm going to, so this is what I would do if I were you. So remember that the two x values that I'm looking at are positive 8 and negative 5. So this is what I did on my graph. Look at my calculator again. When I went to my window, look what I did for my minimum one. If this was negative 5, I said, let me go one more, negative 6. And if it was 8, let me go one more. It's 9, right? And then for my y min, I just said, I just threw out a number, negative 25 and positive 25, right? So then when I do my graph, that's what I'm coming up with, right? Now, again, I can see that I'm good for this part. I'm not good enough. I don't see the whole bottom part, right? But if I wanted to, I could come back and I could say, look, let me let my y minimum here, I don't know, let me go negative 35. Let me see if that does it. Is that going to be enough for me to see the whole picture? Not quite, but I kind of get an idea. You see what I'm saying? Like I kind of get an idea that the x squared graph is the top one. Does that make sense? Yeah, I don't necessarily need to see like with a point where they meet. I mean, if I wanted to, I could say, look, let me go negative 50. Let's see what that's going to look like. That'll probably do it. I'm hoping it would. Boom, there we go. So we can see it now, right? You know what I'm saying? But I just have to play with the window a little bit. Does that make sense?
And how do you calculate the actual area?
Okay, so the way we calculate the actual area is we're going to integrate. In this case, you guys, we're going to integrate from 5 to 8. Of the top function minus the bottom function. Okay. So look, we're going to go from negative 5 to 8. The top function, you guys, is this one right here. It was the x squared function. It was the parabola. So I'm going to go 19 minus x squared minus the bottom function, negative 3x minus 21 dx. Okay. So again, I'm just going to keep writing here from negative 5 to 8. 19 minus x squared. Look, guys, that becomes a positive 3x and a positive 21. Okay. I don't even think I need to even do all this because, look, guys, this is going to be a definite integral. So look, negative x squared plus 3x plus 40 dx, right? Right, because 19 and 21 is 40. So, guys, you know what I'm going to do this problem? Calculator, right? I'm going to go math. I'm going to scroll down to, here we go, function integral. Okay, so my expression is negative x squared positive 3x positive 40, okay, comma x, comma, my lower limit is a negative 5, comma, my upper limit is an 8. I'm going to enter that in, and I'm coming up with 366 point, I don't know. Yeah. 366.167, right? I'm just going to round to 3 decimal places. And let me come back this way. 366.167. Right. All right. So guys, I'm just going to check one thing real quick. Okay. Let me take a look at the next problem here. That was 26. Let's take a look at 27. Okay, let's see. I'm just trying to see if anybody else. Oh man, I heard the. Which, I'm sorry, Matthias. I just saw that you put a comment. Which was the one that you didn't like? Oh, the box one. Yeah. Okay. Yeah, they can take a little bit of time to do. Okay. So guys, let's take a look at the next problem that we got here. Let's do this. Number 27. Okay. Okay, so it says, find the volume of a solid obtained by rotating the region bounded by y equals 8x squared, x equals 1, and y equals 0 about the x-axis. Okay, so first thing is, my equation is y equals x squared. I'm doing this about x equals 1, y equals 0. This is being rotated about the x-axis. Okay. So first thing I'm going to do, guys, I'm going to draw a picture here. Okay. So look, there's x equals 1. Since this is a y equals 8x squared, 1, 2, 3, 4, 5, 6, 7, 8. That's what y equals 8x squared is going to look like. At least that's that half of the graph, okay? Now, I'm going to bound that by x equals 1. So this part right here, that's x equals 1. And we're also going to bound that by y equals 0, which is this piece right here. So guys, this is the part that we are going to rotate, okay? That's the part that we're going to rotate. We're rotating this about the x-axis, so we're going in this direction. So just to give you a heads up, 2, 3, 4, 5, 6, 7, 8, something like this, right? This piece is going to look something like that too. Okay, so the first thing we're going to do, guys, we're going to use what we call the Diff Method, okay? So the Diff Method says we're going to take these little discs, okay? They're going to look something like this. Let me see if I can make that a little bit thicker. There we go, okay? The thickness of that disc, you guys, is going to be an infinitesimally small disc of a thickness dx, okay? Now, the radius of that disc, the radius, you guys, is just the height of the function, which happens to be 8x squared, okay? So we have, you guys, we have these little volumes of these little cylinders, okay? So the way we find the volume of a cylinder, it is always pi r squared times h, okay? So the volume is always going to be pi r squared times h. That's always going to be my volume anytime I'm dealing with a cylinder. Guys, whether that cylinder looks like this or whether that cylinder looks like that, right? It's still a cylinder, okay? So look, let's see if we can find the volume. First thing is pi. Now, we're going to integrate. We're going to integrate for our limits here from 0 to 1. The radius right now, guys, is 8x squared. We need to find the radius squared. So the radius squared would actually be 64x to the fourth, because we got to square that whole thing, right? So look, 64x to the fourth. The height is just that little small thickness dx. Okay? So now, all I'm going to do here, guys, is we're going to leave our pi on the outside. We're going to find the antiderivative of 64x to the fourth. That should be 64x to the fifth over 5 from 0 to 1. Yeah, we could use our calculator here. It's still a definite integral, right? Yeah, I guess, I don't know. I always got used to doing these by hand. But anywho, and guys, look, this is what I'm going to do. When I plug in a 1 to the fifth, still 1, isn't it? So wouldn't this be a 64 pi over 5? Because when I plug in a 0, it's going to give me a 0. Yeah, so that gives me my exact answer. I guess that's why I'm doing it that way. But again, you know, we could do the definite integral trick on our calculator. That's definitely going to work here. So look, guys, right here, I'm just going to enter in fraction 64 pi all over 5. Minute, and there we go. Okay, I think I heard something in the chat, did I? No. Okay, maybe not. Okay, so look, that was 27. So look, let's do 28. It's the same type of a problem here, you guys. Okay, so let me go ahead and copy this guy here. And again, we'll go through the process. I'll draw the picture and the whole 9 yards. Okay. So look what it says. It says determine the volume generated by determine the volume of the solid generated by rotating the function f of x equals 1 over the square root of x about the x-axis bounded by x equals 3 and x equals 4. Okay. First thing I'm going to do, draw a picture. Okay. 1, 2, 3, and 4. 1 over the square root of x. Okay, so at 1, the square root of 1 is still 1. And at 4, you know what? That's not how it looks. At 1, that's 1. At 4, it would be 1/2. So it'd be something like this. This is what that function is going to kind of look like. Okay, so guys, just to give you an idea, how did I draw this picture? I first decided, let me plug in 1. When x is 1, that gives me 1 over the square root of 1, which is 1 over 1, it's just 1, right? And then I said, look, let's do it at 4. 1 over the square root of 4 is 1/2. So say that's 1, then 1/2 is right there. The graph is obviously getting smaller, so it's going to look something like this, right? And then what we're going to do is we're going to bound this by x equals 3 and x equals 4. So we're only looking at this piece here, and we're going to rotate it also about the x-axis, right? So it's going to kind of have like a mirror image like this, right? Does that make sense? Something like that, right? And we're going to have these little discs again, right? So remember, we're going to have these little discs. Look, guys, the radius is just 1 over the square root of x. It's just the height of that function, right? And then we're going to have to square it. So look, the radius squared would be 1 over the square root of x squared. Wouldn't that just be 1 over x? Okay, so remember, y'all, the formula for the volume of a cylinder is pi r squared times h. So it's pi r squared, we just found to be 1 over x. The h is that little tiny dx, right? Okay, so look now, y'all, we're going to do this. We're going to integrate from 3 to 4 of a pi 1 over x dx. Again, if you want to use it, let's use the calculator. So we don't got to mess with it. And then let's see what we come up with, right? I'm sorry? Oh yeah, multiply by pi? Yeah. So look, okay, first thing we're going to do, we're going to go 1 over x, right? Okay, comma x, comma 3, comma 4, close it off, hit enter. Okay, multiply it by pi, because we still got that. And I'm coming up with 9.0, I don't know, 38. Okay, so let's take a look right here, guys. I'm going to put 0.90, what do we say, 38. Let's submit it. Isn't it natural log 4 minus natural log 3? There you go. Yeah. Okay, we got it. So I think that, guys, I don't know about you guys, but now that we know about that little function integral feature, it definitely saves me some time, right, in doing some of these problems. So if you notice, like on this problem here, I didn't even figure it out, right? Now, if I wanted to figure it out, I know that the antiderivative of 1 over x is the natural log x from 4 to 3. So this just becomes the natural log of 4 minus the natural log of 3 times pi, right? And we could enter in our answer that way, right? That would be fine too. But the idea here, guys, is, you know, you can do it that way, and there's nothing wrong with doing it. This is how we did it when we went over this section. It's just that now that we know about the function integral feature in the calculator, it just saves me some time. Now again, my open math is very forgiving, and they let us do decimal approximations, right? You know, sometimes they ask for something what they call the exact answer, right? And sometimes in math they ask for the exact answer. This here would be an exact answer. What we came up with here is what we call an approximation, right? But my open math is real forgiving. They're like, hey, give me either one of the two. We're going to be fine. This one here? Yeah. All right. So look, guys, we're almost done. We got 2 more problems, and then we is done. Okay. Same type of problem here, guys. The one thing I want to mention, because this is a volume problem, and I want you to notice the last 2 volume problems we did compared to this one. So the last 2 volume problems we did, guys, we were rotating everything about the what? The x-axis. Okay. When we go about the x-axis, I always use the disk method. Okay. When I'm rotating about the y-axis, this is when we use the shell method. Okay. So look, first thing here, let's see. Y equals x squared, y equals 0, x equals 5. Okay, so first thing I'm going to do, guys, I'm going to draw a picture. Okay. Okay, I got to go all the way to x equals 5. Yeah, come on. 1, 2, 3, 4, 5. Okay, so I'm going to do it like this. So when x equals 5, y is 25 into this function right here. Okay. Now, so x equals 5. Guys, that is going to be a vertical line going right there. Okay. Now, we're also going to do y equals 0. Y equals 0 is this horizontal line right here. This is the area that we are looking at rotating, but we are now rotating this not about the x-axis, but we are rotating this about the what? The y-axis, right? So it looks something like that. Okay, guys, this is when we use the method of shells, okay? Remember what the method of shells is. The method of shells says, look, I'm going to draw a real small rectangle. Okay? Yes, and then what we're going to do is we're going to rotate that rectangle across. Okay? And what we do is we end up with this little kind of thing like that, right? Almost remember I told you, like if you took a stick of gum, like a juicy fruit, and you kind of made a little, you connected the butt and the tail, right, or the butt and the head. Okay, so guys, remember what we're going to do now. We're going to say, look, the radius from here to here is x, right? The height of this thing here is f of x, and the thickness of that is that little dx, okay? Now, if I took that little piece of gum and I extended it out, right, so that it looked something like this, okay, then we would say the distance from here to here is 2 pi x. Why? Because that is the circumference of the circle. The circumference is always 2 pi r. R in this case is my x. The height of this thing here is my f of x, and then the little thickness of it is that little dx, right? So now what we have, guys, we have a little rectangular solid. And the way we find the formula of a rectangular, or the volume of a rectangular solid, is always the length times the width times the height, okay? So in this case, the volume is going to be 2 pi x times my f of x times my dx, okay? So look, we're going to integrate from 2 pi, okay, 2 pi. We're going to integrate, you guys, from 0 to 5 of x times f of x. Look what my f of x was. F of x was an x squared function, okay? So I'm going to have a 2 pi from 0 to 5. X times x squared is going to give me x to the third. Guys, can I just plug this into my calculator now? Let's do it to it. Okay. So we're going to come over here. Let's turn this guy on. Let me clear. Let's go to math. Let's go to our function interval. Here we go. Okay, so I'm going to enter in x to the third. So x to the third, okay, comma x, comma 0, comma 5, hit enter. And then when we get that, we still got to multiply it by what?
2 pi.
By 2 pi, right? Because that's the number that's in front. Times 2 pi. So I'm coming up with 981.75 or 7477, right? Okay, so let's try that. 981.7477. I think too many sevens. Submit it. And we're done, right?
So the algorithm is just 2 pi, the function is ordered is 2 pi.
Yeah, the thing about
is the function dx.
That's right. That's right. All right, guys. Last problem here. Let's make it count. Okay, so I'm going to do a little copy. Yes, and we're going to do a little paste. Okay, so right here. Now, guys, one thing I want to mention before I go ahead and do this problem here, come back over here. So, yeah, so guys, in my info here, I gave you guys a formula sheet for chapter 6, just to let you know there's like formula sheet test 1, test 2. and from chapter 6. So, like here's the volume by disks, right? Here's the volume by shell. So John, you were asking right now, it's 2 pi the integral x f of x dx, right? Here is my formula for the arc length, okay? So again, guys, if you have an arc length problem, make sure that you do use the formula sheet, right? That's why it's there, so that you guys have something to go back and reference to, okay? So let me do this right here. Okay, now we can do this. I didn't copy the problem. But I did. Oh, maybe I did. Copy this here, copy. Yeah, I guess I thought I did. Fixed. Okay, there we go. Arc length. Find the arc length of y equals 4x squared minus 1 over the interval from 0 to 3. Okay, so the first thing I need to do here, guys, obviously, is I need to find f prime of x. So if this is my f of x, wouldn't my f prime of x be an 8x? Because I'm taking the derivative. And then I need to find that derivative being squared. 64x squared, right? Okay, so now we're going to find the length. We're going to integrate from 0 to 3 in this case of the square root of 1 plus 64x squared dx. Again, now guys, all I'm going to do is use my calculator, right? Boom. Second square root 1 plus 64x squared. Okay. Close my parenthesis, comma x, comma 0, comma 3. Hit enter. And I'm coming up with 36.2732.
Much nicer than the actual exact answer. The natural log of the square root of 577 plus 24 divided by all this divided by 60 plus 3 times the square root of 577 plus.
There you go. So again, guys, the main thing is, when you can use the calculator, it definitely saves you time. The important part you need to know how do I find the arc length though, right? Because you got to know what I'm going to plug into my, you know what I'm saying? You got to know that part. But again, that's why you have the formula sheets there, okay? So again, y'all, as you're going through this stuff here, let me go ahead and just close that up. As you're going through this stuff here, remember, in this little deal here where I have the final exam info, I do have like the formula sheet for test 1, the one for test 2, and from chapter 6. So guys, the test is going to open up today. Let me do this real quick. I just want to make sure that my settings are the way they're supposed to be. Let's go here. Let's go to settings. Okay. You can take the test twice. You get 5 questions, 5 tries on each question, guys. Okay, so you should be good. Make sure there is no time limit. No time limit. Okay. Okay, so we're good there, guys. So guys, the test is going to open up in about an hour, right? It's due. Anybody know when it's due? Guess again. When is the final due? Right here. Oh, it is the 12th. I'm sorry, the 12th. Okay, what time? 8 o'clock, right? Okay, I'm sorry. I was thinking you were saying it's due at 12. No, you're right. You're right. It is due the 12th. My bad. It's due the 12th, guys, at 8 o'clock. Okay. So it's due by Thursday. You got the whole week to get it done. Guys, take your time, right? Remember, you can do it in pieces. You got 20 questions, right? So take your time with it. Guys, I am going to go ahead and stop hitting record right now.